Hello class, welcome to this lesson. We're talking about the second lesson of Unit 6. We're talking about applications of the normal distribution. So continuation of the normal distribution intro from last section, but now we're going to actually apply those ideas here. So we want to talk about how do we calculate the probability that a value falls within a given interval in a normal distribution. We want to find a value corresponding to a given probability or area in a normal distribution. So how can we use the normal distribution to find the probability that a value falls within a certain range or to find the value given a probability? So we're going to just review this vocabulary. This is just vocab that will be introduced in the lesson that was actually discussed in the previous one. The normal distribution, standard normal distribution, and the z-score. All right, so the standard normal distribution, remember, can be used for a variety of purposes. So we're going to actually use it to solve certain problems. It can only be used in these problems, however, if the random variable involved is normally or approximately normally distributed. So most of the problems in here, you will assume that the distribution is actually normal. However, later we'll actually look at, in another lesson, how to determine normality. That is, to determine if a variable is normally distributed or not. So in the previous lesson, we discussed the properties of a normal distribution and the standard normal distribution. So on the left is the normal distribution, which can have a mean of any value and located in the middle, in this case the mean being 100, and the standard deviation in this case being 15, as you can see that it is spaced by 15 on each side. On the right is the standard normal distribution, which remember is very specific and starts with a mean of 0 and with a spread or standard deviation of 1. Now to convert the x values in the normal distribution into the values 0, 1, 2, 3, which are in the standard normal distribution, we must use the z-score formula. So notice that this is the x distribution, and we want to convert it over into the standard normal distribution, which involves the z-axis. So our goal is to convert x to z. How do we do that? We use the z-score formula given below. So suppose that the distribution above represents the weight distribution of a population of middle school students, where the average is 100 pounds, and the standard deviation, which is the average and the spread in the weight from the mean, is 15 pounds. What is the z-score of a student who has a weight or x value of 100? So supposing that this is the weight distribution, then we're looking at the x value of 100. So in order to calculate that, when we know that x is equal to 100, and we know that the mean is 100, and the standard deviation is 15 pounds, so therefore we can actually go ahead and calculate the z-score, x minus mu over sigma, which is 100 minus 100 over 15, which in this case the z-score is going to be 0. So this is just saying that 100 is going to turn into 0 when we convert it to a z-score, which makes sense since they're both in the middle. Now for the next part, what is the z-score of a student who has a weight of 130? Well, this time the x value is 130, so we're going to minus it by the weight, or the average weight in the middle, 100, divided by 15. So you're going to get 30 over 15, or 2. So this means that you have a z-score of 2. So the 130 pounds here corresponds to a z-score of 2, which makes sense because they're spaced 2 apart, because the standard deviation is 2. Remember that the z-score represents the number of standard deviations from the mean. So this makes sense that 130 pounds is 2 standard deviations above the mean. So this makes sense. All right, so then the next thing we want to do is calculate the z-score of a student who has a weight of 77 pounds. So we have z equals 77 minus 100 over 15. So 77 minus 100 is 23 over 15. Now it's important to note that when you calculate a z-score, you want to round it to 2 decimal places because of the purposes of using it later for the z-chart. So if you go ahead and divide this to 2 decimal places, you get approximately 1.53. All right, so now this indicates, so 177 pounds is somewhere in this neighborhood. And if you see that kind of corresponds, this should be a negative number, negative 1.53. That kind of corresponds to about halfway between -2 and -1, which makes sense because it's halfway between those two values. So this is negative 1.53, and this is approximately 77 pounds. So this makes sense. All right, so now you know that the correlation between the x value and the z-score. So now the reason why we convert the x values to the z-scores is because the standard normal distribution, which is the z-scores, we use that table in order to find the areas under the curve. So you could take any normal distribution, convert it to the z-score, and use the z-score to find the area under the curve. So how do we find the area under the curve? Well, first, you're going to draw a normal curve, shade the desired area. This serves as a visual to make sure that you're calculating the correct value to make sure that your answer makes sense. Then step 2, you're going to convert the values of x to z values using the formula z equals x minus mu over sigma. And then you're going to use the z table in order to actually determine the actual value, or you can use a calculator or software. Now the calculator, you have to use a sophisticated calculator, so a scientific calculator will not suffice to calculate these. So we'll be using the table in this course. All right, so let's look at an example. So an adult has on average 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. Find the percentage of people who have less than 5.4 liters of blood in their system. So step 1, you want to actually identify your average, which is your mean, your mu, and your sigma, which is your standard deviation. Then you want to identify the x value. So in this case, we know that the mu is 5.2 because we have an average of 5.2 liters. The standard deviation is 0.3, that's sigma, and we want less than 5.4 liters of blood. So this is actually going to be less than 5.4. Because it's less than 5.4, we draw a normal distribution for the first step. Remember that this is the x values, so 5.2 is the average in the middle. Remember that mu is in the middle. And then you're going to add one standard deviation on each side and then keep going. So you're going to add 0.3 on each side because that's the standard deviation according to this. Okay? So that's why you're going to go by 0.3 on each side. And then you're going to go 5.4 is pretty close to 5.5, so we draw a vertical line there and we shade to the left. So that's step 1, is to be able to draw this out and shade the correct area. Next step, you want to actually calculate the z-score. So we know that x is 5.4, so we simply calculate it. And here we got 5.4 minus 5.2 divided by 0.3, and we get 0.67. Remember, we want to calculate it to 2 decimal places. So then I went ahead and redrew the normal distribution. This time I converted the x to the z. So this is just a generic normal distribution when we do x, and then we converted it to the standard normal distribution with 0 in the middle and 1 on each side. All right, so now we got 0.67 is pretty close to 1, and this makes sense. All right, now that serves as a nice visual, you can actually correlate it to the table. So step 3, we're going to actually calculate the value. Remember that to calculate a value to the left of a z-score, we just have to look it up on the table. So we're going to look it up right here. We need to look at the positive values, however. So let's go to positive 0.67, 0.67, and then find the score from there. So we have an area of 0.7486. So that's my probability, 0.7486. So this means that in this example, we're talking about the adults, the percentage of people. So this means that 74.86% of people have less than, in this case, less than 5.4 liters of blood in their system. All right. right, so now each month an American household generates an average of 28 pounds of newspaper for garbage or recycling. Assume the variable is approximately normally distributed and the standard deviation is 2 pounds. If a household is selected at random, find the probability of its generating between 27 and 31 pounds per month and more than 30.2 pounds per month. So looking at the first part, between 27 and 31 pounds per month, that equates to an x value between 27 and 31. The mu they told us was 28 and the standard deviation is 2, so that's sigma. So we go ahead and calculate or draw the normal curve with 28 as the mu in the middle and spaced by the sigma, which in this case is +2 or -2 on each side. And then we want between 27 and 31 pounds, and we shade in between those. The next step now, we want to actually calculate the z-scores. We have to calculate two z-scores, one for this from 27 and the other one for 31. So we're going to calculate those two z-scores using the same formula. This time, remember, x1 is 27, x2 is 31. So we plug those numbers in, we know that the mu is 28, the sigma is 2, and we get those two z-scores. Went ahead and redrew the distribution with the z scores on the z-axis, 0 in the middle, going by 1 on each side. All right, so now we shaded those. We're ready to actually compute the area under the curve. So we're going to have to subtract the two areas for both z-scores from the table. Remember that you take the right z-score minus the left z-score. Okay, so you take the right one minus the left one, and then you calculate the area. The area should always be positive. So in this case, we're going to look up both values here. So we have 1.50. So we got 1.50, which correlates to an area of 0.9332. Minus, now we want to look up less, negative 0.50. Negative 0.50. 0.3085. Now we're going to calculate that area. We're going to subtract those two numbers. You got 0.6247. So in this case, if we convert it to the context of the problem, they're asking the percentage, the probability of its generating between 27 and 31 pounds per month. So that's the probability of generating between that much garbage, between those two values. All right, now we're going to look at the part B. What is the probability of its generating more than 30.2 pounds per month? So this time x is greater than 30.2 pounds, and we'll label that on the same curve that we drew earlier. So 30.2 is a little bit greater than 30, so I did it as such, shaded to the right because we want the right area. Now since we want to find the right area and the table gives us the left area, of course we're going to have to subtract it from 1, but we'll do that in the third step. So the second step is to calculate the z-score. So we're going to convert the x value of 30.2 down to, by putting it here into the formula. So 30.2 minus 28 divided by 2, you get 1.10. So now and then I went ahead and redrew the distribution with the z-scores instead. Now we're going to actually write down, remember, to find the area on the right side. This is the right because it's greater than. You got to do 1 minus the left side. And the table gives you the left side, so this is going to be looked up from the table. So it's 1 minus the table value. So now we're going to look it up on the table, 1.1, 1.10, so we got 1.10, which in this case is 0.8643. So we're going to do 1 minus 0.8643, which is 0.1357. So the probability of finding a household that's generating that much or more, like greater than, in this case, greater than 30.2 pounds of garbage, is about 13, almost 14%. So it's kind of low to find somebody that is generating that much garbage. All right, so now we're going to look at a normal distribution problem that asks the question how many rather than what is the probability. So a desktop PC uses 120 watts of electricity per hour based on 4 hours of use per day. Assume the variable is approximately normally distributed and the standard deviation is 6. If 500 PCs are selected, approximately how many will use less than 106 watts of power? So the random variable x is the power usage, the wattage, and we're interested in how many computers out of the 500 will use less than 106 watts of power. So we're going to answer this question by doing what we've done previously, by finding the probability using those 3 steps, and then we multiply the 500 PCs by that percentage to obtain how many will actually have less than that much power. So step 1, we know that the mean is 120. The average PC uses 120 watts of electricity with a standard deviation of 6. And then we're looking for less than 106. So x is less than 106. So we draw the normal distribution with the mean in the middle, spaced out by the standard deviation of 6 and minus 6 on each side. So next step, we want to actually calculate the z-score. So we're going to convert the 106 into a z-score of negative 2.33 by plugging it into the formula right here, 106 minus 120 divided by 6. Now that we have the z-score, we can find the area to the left by looking the value up in the table. So we simply got to look up the z-score from the table. The table gives us the area to the left by default, so we can just look it up and be fine. So we have negative 2.33, so negative 2.33. So the area is 0.0099. And remember that since we want the area on the left side, we just have to use that number. So 0.0099. Want to make sure that number is correct. Yes. And then we're going to take, so basically this is about 1%, or less than 1%, right? This is almost 1%, it's 0.99. So we're going to take that decimal, we're going to multiply by 500. And that will tell us about how many PCs use that much power. Now we know that should be very small because the area here is very small. So there shouldn't be that many PCs using that much power. So in fact, if you multiply those two together, you get about 4.95 PCs. Now we know we can't have a decimal for 4.95 PCs because that doesn't make any sense. So therefore we're going to round this to approximately 5 PCs. So out of the 500 PCs, which we multiplied by, we get 5 of them use that much power or less. All right, so how do we find the data value given a specific probability? This time they give you an area, and then you have to figure out what the x value is. So remember that a normal distribution can be used to find specific data values as well as the percentage. So you can, do vice versa. So in this case, you are given a probability or a percentage and you want to find the data value x. So in order to do this, we need to actually use the formula for the z-score and solve for x. So this is what we're going to show you how to do. So remember that the z-score formula is x minus mu divided by sigma, lowercase sigma. So what we want to do is we want to solve for x here so that we can get a formula where we can just plug in and get x. So in order to solve for x here, I'm going to use a little bit of algebra. So I need to get rid of the sigma on the bottom, and right now it's dividing on the bottom, so I'm going to multiply both sides by sigma and that will cancel it out. So I'm going to do that here, and I'm going to do that on this side as well. So that now the sigmas will cancel out because sigma divided by sigma is just going to be 1. So now we have z times sigma equals x minus mu. And then since we're solving for x, we're going to get rid of the mu by adding mu to both sides. So in this case, we get z times sigma plus mu equals x. And this is our formula for x. Okay, so basically to get x, you got to find the z-score, you got to know what sigma is, and you got to know what mu is. All right, I went ahead and just and show you where that I showed you that formula right here in a nicer format. So to get x, we want to take the z times the sigma plus the mu. And that's how we get that formula which we solved for earlier. Now the procedure for finding the data values is given below. So the first step is you want to draw a normal curve, just like we normally do, and shade the desired area that represents the probability. And then you want to find the z value. Instead of finding the x value, you want to find the z value first. That corresponds to the given area. And then calculate the x value. Once you find that z value, you can plug that z value into the formula and get your x. All right, so we're going to show you how this works. So to qualify for a police academy, candidates must score in the top 10% on a general abilities test. Assume the test scores are normally distributed and the test has a mean of 200 and a standard deviation of 20. Find the lowest possible score to qualify. All right, so the step one is to draw the normal distribution and shade the indicated percentage that they want. So in this case, the mean is 200 because we want the average score, and the standard deviation is 20. Now we want the top 10% to qualify, right? The top 10% of scores. So the top 10% means we're shading the area on the right side of the 10%. So we're looking for the right 10% on the table. If they wanted the bottom 10%, that would be, like on this left side, right? But they don't want that, right? They don't want people on the bottom 10%. They want the most qualified. So now step two, we want to work backwards to solve the problem. So since the table gives you the area to the left, we want to find the area on the right side, which we know it's 0.10, then we need to subtract 1 minus the area that we have. So we're going to do 1 minus the 10%, and that gives us 90%. So now we know that the area on the left side is 90%, and we can look up, this is the same thing as 0.9000, and then we can look this up on the table. All right, so step two, we want to find the z-score by looking up the area. Remember that we said that the area on the left is 0.9000, so we want to actually look up that value. Remember, we're trying to find the z-score here, right? So we're gonna work backwards here. We need to find an area that is 0.9000 and use that to find the z-score. So right now these areas are very small, so we probably don't want to look on this side of the table. So let's scroll over to the right side. We want to get as close to 0.900 as possible. And it looks like the closest area to 0.9000 is 0.8997. Can you see that? 0.8997. And now you're going to find the z-score that corresponds to that. So we're working backwards here. So we get a z-score of 1.2. And then 2 what? So we got to go up here. So it looks like 1.28 is the z-score that we're looking for, approximately. So the z-score is approximately 1.28. So I'm going to put an approximately symbol, 1.28 right here. All right, so that is step two. So now we got the z-score of 1.28. We're going to do step three, which means plug that z-score into the x formula. So we got 1.28 here, times the sigma of 20 plus the mu. And in that case, you get a x value of 225.6, which we're going to round to 226. So this means that a score of 226 should be used as a cutoff to determine those that qualify for the academy. So anybody that scores that score or higher will qualify. All right, let's look at another example. So for a medical study, a researcher wishes to select people in the middle 60% of the population based off of blood pressure. Assuming that blood pressure readings are normally distributed and the mean systolic blood pressure is 120 and the standard deviation is 8, find the upper and lower readings that would qualify people to participate in the study. All right, so we know that the average is 120, the standard deviation is 8, and we want to figure out the upper and lower readings because we're looking for the middle 60%. So the middle 60% is given in the shaded area. So this is in between those two values of x that we're looking for. So we're trying to figure out what those two x values are that give you the middle 60%. So those right now are a question mark. Now, since we know that this middle part is 60%, and this curve is symmetric, this means that both of these sides had to add up to 40%. 40% plus 60% is 100%, which means that if we take 40% divided by 2, that's going to give us 20%. So therefore, we have 20% on each side. All right, this is going to help us because in in this step, we want to figure out the area to the left of x2 and the area to the left of x1, because these areas are going to help us find the z-scores on the table. So the area to the left of x2, as we mentioned earlier, is 20%, because we calculated that earlier. Now we can convert the 20% to 0.2000. Now the area to the left of x1 is the 60% here plus the 20% there, for a total of 80%. So this time we want to use 0.8000 for that area. All right, so now we got the areas for both of those. So the area for Z1, again, recall, is 0.8000. The area for Z2 is 0.2000. That's too many zeros. All right, so now that we got those two areas, we're going to look them up on the table. So let's look up 0.8000 first. So if we look at here, the areas, the closest value to 0.8000 is 0.7995 right here. So therefore, I'm going to find the z-score that corresponds to that. So that's 0.84. So 0.84 is my z-score. So that's my z1. Now my z2, I need an area of 0.2000. So an area of 0.200. The closest area to that seems to be 0.2005. So therefore I'm going to look that z-score up, which is going to be negative 0.84. All right, so now we know it's negative 0.84 and positive 0.84. All right, so now we got those two z-scores. Now the next step is to compute the x values by plugging in the z-scores, which you can see here and here. We plug those in and we get those two x values. Now because we know our mu and our sigma. All right, so this means that the middle 60% of people will have blood pressure readings between 113.28 and 126.72, and that is in millimeters of mercury. All right, guys, that's it for the video. I hope you learned a few things from this lesson, and I will see you in the next one.